Hello, we're going to take a look at using some of these new trig equations. These are the sum and difference formulas. So we figured out kind of how to arrive at these formulas, but now I want to use them. So these are the examples from class. And I'm just going to do them so that if in class it went too quickly or you just want to see it again, you'll see how these work. So we have, and I realize that you can't tell where I'm pointing. We have these formulas derived. uh, Cosine and sine, sum and difference formulas where A and B are two different angles. And we have our first problem, find the exact value of sine 15. So sine 15 is not a unit circle value, but 15 is equal to, for example, 45 minus 30 or 60 minus 45. It actually doesn't matter which two you use as long as you get to 15. So we're going to apply the formula so that we have sine of I'm going to use 45 minus 30. Seems like the most obvious one to do. All right. So 45 minus 30 is 15. So I'm just replacing 45 minus 30 with 15. And therefore, I'm going to use this last formula on the page. And that is going to equal sine. I'm just using A as 45 and B as 30. So sine of 45, cosine of 30. And minus sign means minus sign. If I use minus here and here, they go together. So we're going to subtract cosine of A was 45, 45 times sine of 30. Okay. Now we can evaluate all those from the unit circle. Sine of 45, I hope I get this right, is root 2 over 2. Cosine of 30, that's the lower triangle. Cosine value is root 3 over 2. Minus cosine of 45 is root 2 over 2 again. And sine of 30 is that's also the lower triangle. Same triangle as cosine of 30, but it's the other part of it. It's the vertical part, so that's 1/2. And then just multiply and simplify these. So root 2 times root 3 is root 6 over 4 minus root 2 times 1 is root 2 over 4. And you can even rewrite that as root 6 minus 2 over 4. And you're done. So that's the first one. I'm going to erase the screen and go to the second one. Erase the screen. Clear all drawings. There we go. All right, so find the exact value of cosine 50, cosine 10 minus sine 50, sine 10. So this kind of looks like the same structure as this one, where A is 50 and B is 10 and A is 50 again and B is 10. So I'm going to use this backwards. So that means that this is equal to, and this is a minus sign. That's actually, you got to be careful about. That's the minus sign, goes with this minus sign. So this is a plus sign. So that equals cosine of 50 plus 10, which equals cosine of 60. And cosine of 60, that's this triangle up here. Cosine value is root 3 over 2. So that's your answer there. Now, B is in radians. This is one where there's a sine and a cosine next to each other, a sine and a cosine next to each other. So that's the sine equations, one of these two. There's a plus sign here, so the plus sign here. So we're in this equation. And A is 5 pi over 12. And B is 1 pi over 12. So using substitution working backwards, this is equal to sine of 5 pi over 12 plus pi over 12, all in parentheses. 5 pi over 12 plus 1 pi over 12 is 6 pi over 12, also known as pi over 2. So sine of pi over 2 is what we're actually evaluating. Sine of pi over 2, and we're using these equations backwards, basically, or backwards from number 1. Sine of pi over 2 is equal to, let's see, sine of pi over 2 is top of the circle, so that's equal to 1. There we go. All right, so that's those two. Oh, I'm going to have to adjust the screen to see the bottom one. Let me clear the screen. Take me a second here. I'm not very good at this. Let's do a little adjustment like that. Okay. Go back to annotate. And suppose sine A is 4/5 in quadrant 1. Okay, so you know how to graph that. You know how to do a visual of that. And sine B is 5/3 in quadrant 2. Okay, let's take a look at both of those. Find cosine of A over B. Okay, so let's do a little drawing. The first one, A. This is A. So we're in quadrant 1. We draw a triangle where sine is 4/5. Okay, so that means opposite is 4, hypotenuse is 5. We're not in the unit circle anymore. Here's theta. That's Pythagorean triple, so I also know that this value is 3. Doing a drawing for B. We've done drawings like this many, many times. Drawing for B. Now we're in quadrant 2, so I'm going to draw it over here. Quadrant 2. This is sine also. Sine B is 5/13. So sine is your y value. So this is 5. This is 13. Sine is that opposite one. And then this is 12. But because we're in quadrant 2, we're going to call that -12. Now you can read, here's theta. You can read, in fact, theta is B. And theta here is A, the first one. So you can read sine, cosine, tangent, whatever you want out of those triangles. It wants us to find cosine A plus B. So we're going to use this equation. Cosine of the A triangle is 3/5. Cosine of the B triangle is -12 over 13. Minus sine of the A triangle, which was given to us, by the way. Sine was 4/5. And sine of the B triangle, that was given to us, but it's in the triangle, is 5/13. And just do the math here. So multiply the two fractions and then subtract them. The denominators are both 65. I do these down here. Denominators are both 65. It's convenient that they come out to common denominators for us. Both denominators are 5 times 13, which is 65. And 3 times -12 is -36. And 4 times 5 is 20. There's a negative sign there. So this is -56 over 65, right? And that's what cosine of A plus B equals cosine A plus B. Now notice it's the output of cosine. So it needs to be in between -1 and 1, which it is. It's a fraction smaller than 1 with a negative sign. So there you go. There's the 3 examples we did in class. You can go through it however you want to, slowly, quickly. Not at all because we did it in class. Whatever you want to do. Maybe we didn't get to it in class. I don't know. Sometimes that happens.